Do you remember this? Simplifying, what do you have to use? You have to divide by a what? Perfect square. Oh, why is it frozen again? Sorry. You have to find a perfect square that goes into that number, and then divide, and then simplify. Okay? All right, and rationalizing the denominator, you have to multiply by whatever the root is in the denominator, and then you end up with that. So, today, let's start by evaluating the 6 trig functions of angle theta in both triangles below. Now, there's only one triangle in the triangle below. So you have to reduce and rationalize if needed. No decimals, basically, is what's happening here. All right, so the first thing I would do is I notice there's a missing side. So I'm going to find out what the hypotenuse is. This, from theta, this would be the adjacent leg. This would be the opposite leg. This is obviously the hypotenuse. You may remember a right triangle with legs 3 and 4 is a special right triangle. Do you remember what the hypotenuse is? Without doing the Pythagorean theorem? 5. It is 5. If you don't remember that, you can always use the Pythagorean theorem. So the first step would be to find the missing side. Of the right triangle. Here, since it's a special right triangle, the hypotenuse is equal to 5. If you can't remember that, just use the Pythagorean theorem. Okay. So now it's telling us to list all the trig functions. So now I'm going to list all the ratios. I'm going to start with the normal ones that we learned, sine, cosine, and tangent. And then I can just flip them to get the other ones. So the sine of theta is equal to, the cosine of theta is equal to, and the tangent of theta is equal to. So for sine, from this angle, it's SOH, right? Sine, SOH. So it's opposite over hypotenuse. So what would that ratio be? 4 over 5. Opposite over hypotenuse. Cosine is what? Adjacent over hypotenuse. So from this angle, it's 3 over 5. And tangent is opposite over adjacent, which would be 4/3. And then you can write the other 3. Which one goes with sine again? Cosecant, the one that starts with C. And you just flip it, 5 over 4. And then secant would be 5 over 3. And cotangent would be 3 over 4. So far, so good, yeah? Okay, I know this is exciting. Let's turn the page. It is long, but it's not hard. Okay. Oh, here's the second triangle. This isn't too bad. It's just a little bit different. So here, we got to find the missing side. This is not a special right triangle. You might want to say 5, 12, 13, but it's not because they gave us the hypotenuse here, so you got to be careful. So find the missing side using the Pythagorean theorem. Don't write too big here. So 5 squared plus, I'll call that b squared, equals 12 squared. So this would basically be 144 minus 25, correct? So b squared would be 119. 144 minus 25. There is no way to simplify that, so b is just going to be the square root of 119. You know where we're going with this, hopefully. Rationalizing, okay? So then we're going to write the ratios. Easy enough. The sine of theta, from here, this angle right here, sine is opposite over hypotenuse, opposite over hypotenuse. So it's the square root of 119 over 12. Cosine of theta is from this angle adjacent over hypotenuse. So it's 5 over 12. And then tangent of theta is equal to, from this angle, opposite over adjacent. Opposite over adjacent. Okay, so let's do the reciprocals of those. Cosecant of theta. Okay, so here we have square root of 119 in the denominator. We can't leave that like that. So it actually becomes quite easy once you start doing this over and over again. It's very easy to see what's going to happen. What's going to happen in my denominator is I'm just going to be left with what? 119, and my numerator, I'm just going to be left with 12 times the square root of 119. So the cosecant of theta, it's kind of small here, is 12 times the square root of 119 over 119. You can do that in your head, pretty much, once we keep going here. And then the secant of theta is flipping this one, which would be 12 over 5. And then the cotangent of theta, again, we're going to have to rationalize, but probably, if you think about it, you can just write it rationalized. The numerator would be 5 times the square root of 119 over what? 119. Cool? Okay. If theta is an acute angle of a right triangle and the cosine of theta is 3 over 8, what is the value of the cosecant of theta? Got to do some work probably. I'm a picture person. I have to draw pictures. Draw and label a picture first. Some of you could probably do it in your head, but I can't. So I'm going to draw a right triangle. How's that for a straight hypotenuse? Okay. Then you can pick either acute angle to put theta in. It doesn't matter. I just put theta up here. And then based off the information they gave me right here, I know 2 side lengths already. Because the cosine of theta is 3 over 8. Cosine is adjacent over hypotenuse. So I already know 2 side lengths. So this is the first step. The second step is find the missing side. Because you cannot do cosecant without having this other side here. So you can use the Pythagorean theorem. 3 squared plus b squared equals 8 squared. That would be 64 minus 9. You see that? 64 minus 9. So b squared would be 55. B is the square root of 55. You cannot simplify that any further. Okay, now we can find the sine of theta, and then we can flip it to get the cosecant. Maybe you can do that without doing this step, but sine of theta would be opposite over hypotenuse, which is the square root of 55 over 8. Whatever that is, cosecant is just a reciprocal of this ratio, which obviously you can't leave that square root in the denominator. So how would that be rewritten? Over 55. There you go. Boom. So that's trig ratios. Oh, there's more. Special right triangles. Alrighty. Special right triangles. So this is the first one, and we call it, if this is 90, this is 45, what's this angle measure? So the first one we're going to talk about is a 45, 45, 90 right triangle. In a 45, 45, 90, These legs are going to be what? Congruent. Okay, because they are opposite congruent angles. And the legs are congruent. Just keep that in mind. Legs are congruent. So, does anybody remember, let's say we label this, I don't know, this side A, and this side is also A. Does anybody remember the measure of the hypotenuse then? It is. It's 8 times the square root of 2. So, let me just write that down. If you're given the leg and you need the hypotenuse, you just multiply by the square root of 2. So that means my hypotenuse here is A times the square root of 2. If you're given the hypotenuse and you need to go to get a leg, you would just divide by the square root of 2 and rationalize if necessary, which it will be. All right. The other special right triangle. If this is 90, this is 60, what's this angle measure? 30. So the other special right triangle is 30, 60, 90. You always have to, you need the short leg. Sometimes you're given the hypotenuse and you can find the short leg or vice versa. But let's start with the short leg. We'll label that B. Does anybody remember here? How do you get the hypotenuse if you're given the short leg? It's easy. Times 2, right. The hypotenuse is double the short leg, so 2B. Does anybody remember how to get the long leg? Hint. Here you're using square root of 2. Here you use something else. Square root of something else. 3. Yeah. So if you have the short leg, the long leg is B times the square root of 3. I'm not going to write all that stuff out. You can just use the picture to remind you. So if you were given the hypotenuse, you would divide by 2 to get the short leg, and then you could multiply by the square root of 3 to get the long leg. You did a lot of this last year, or whenever you had geometry. Okay. All right. So let's practice that. Find the missing sides of each right triangle shown. Leave your answers as exact answers. When you see that, what does that mean? No what? No decimals. You got to leave it with the square root. Okay? So here they're giving me their leg. It's a 45, 45, 90. I know the legs are congruent. And then the hypotenuse is 6 times the square root of 2. Here they gave me the short leg, which is nice. All I have to do is double it to get the hypotenuse and multiply it by what to get the long leg? Yeah. Okay, this again is a 45, 45, 90. They gave me the hypotenuse, so what do I have to do to get the leg measures? Thank you, Alex. You are wide awake this morning. I appreciate it. Okay. So now I have to rationalize, which means I have to multiply by the square root of 2 over the square root of 2, and you could probably just do this without writing it all out. But I wanted to write it out because we wouldn't want to leave this in not its most reduced form. So what's 10 divided by 2? 5. 5 times the square root of 2, 5 times the square root of 2. 10 divided by 2 is 5. Okay, 30, 60, 90. They gave me the hypotenuse. What is the length of the short leg? What did we do here? Yes, it's 21. It's half of the hypotenuse. And then we just do 21 times the square root of 3. Coming back to you? Alrighty. So here, this is solving triangles, right triangles, finding all the missing angle and side measures. When you see this, that means this. You find all the missing angles and side measures. Round decimal answers to 2 places, which means we don't have to leave it in square root form, right? We can put it in decimal form. That's always nice. So the first thing we'll do is, let's see, we have these 2 angles. Can we find angle B? Yes. Very easily. Yes, 180 minus 90 minus 54 equals 36 degrees. So the measure of angle B is 36 degrees. I'm going to write that right in my picture too. So partway there. The only thing I need to do now is find the other 2 sides. And I use trig ratios for that. So this was 1, this is 2. You have options. It doesn't matter where you go from. I just chose to go from 54. And the first one I'm going to find, opposite angle A would be lowercase a, and opposite angle B would be lowercase b, just to label the sides. I chose to go from angle 54 and the 54-degree angle and find A here. So I thought I would use a sine ratio, opposite over hypotenuse. It doesn't matter where you go from first. You could use 36 as well. So from the sine of, from 54, opposite over hypotenuse would be A over 20. And basically, to get A by itself, you do what? Multiply both sides by 20. So A is equal to the sine of 54 times 20. This is why you needed a calculator. Make sure your calculator is in degree mode. I'm guessing you know how to do this already. So I can just give you the answer, but give it a try. Just to make sure your calculator is set up right. Degree mode is under mode. It's either radians or degrees, and you want to work in degrees. Because you're entering a degree measure, so you shouldn't have gotten a negative number. Make sure it's in degree mode. Yeah? Sine of 54 times 20. If you push sine of 54, you might need to close the parenthesis first before you multiply by 20. Did you hear that? Because otherwise the calculator is going to do 54 times 20 and try and find the sine of that. And that doesn't work. Okay? All right, you have options now. If you know this is 16.18, for number 3, you could use the Pythagorean theorem or another trig ratio. Probably would be more accurate to use the trig ratio, but because we rounded here. So yeah, that's what I did. I thought, well, why not go from the same angle and do the cosine? It doesn't matter. You could do a different angle if you wanted. Cosine of 54 equals b, the adjacent over the hypotenuse. Again, you're just multiplying the 2 together, and you should get approximately 11.76. Almost done. I thought this one's kind of the same, but the ratio is set up slightly different. I wanted just to refresh your memory what happens when you set up the ratio differently. So when you subtract everything here, the measure of angle A turns out to be 25 degrees, so I'll just do this one kind of quickly. Again, we're solving this right triangle. Now, let's find the hypotenuse first, just because it sets up the ratio differently. It doesn't really matter, you don't have to, but I'm going to do the hypotenuse first, and I'm going to use this angle right here, 65. This is side C, this is side B. So the cosine of 65, if I'm coming from this angle, is equal to the adjacent over the hypotenuse, which would be 15 over C. So this is how I look at it when I'm first teaching this to people. This is really a proportion, isn't it? And if you cross multiply, you're just doing 15 times 1 divided by that, correct? So really all you're doing is 15 divided by that when the variable's in the bottom. So that's kind of what I wanted to remind you of. Cross multiply and divide. Which turns out to be 15 divided by the cosine of 65, which is approximately 35.49, which is my C. All right, now you can use the Pythagorean theorem, or you could use tangent, or you could use whatever to find B. I'm just going to give it to you. And we just would not be doing trig ratios unless we did a story problem. Great. Okay, you're hiking towards a main road, but reach a point where the road is flooded. Okay, so I just started to draw a picture. Here I'm hiking towards a main road. Here's my main road. Hiking towards a main road. I hit a flood. Flood. To avoid the flooded area, you turn onto a diagonal road that meets your original road, that's this road, at 48 degrees. And you follow that road for 3.6 miles until you hit the main road. How far were you from the main road when you turned onto the diagonal road? So I'm hiking up here, I see a flood, and I turn at a 48-degree angle. And I'm on this road for 3.6 miles. Then I need to know how far I was from the main road before I turned. Oh, look. We have to assume that this is a right triangle. Sometimes assumptions are necessary. So we can use a trig ratio. Which one would I use to find this? Adjacent, hypotenuse. So which one would I use? Cosine. Cosine of 48 equals x over 3.6. So then you just cross multiply, which would ultimately be multiplying these two together. Again, please, please be careful. On the calculator it looks like this, doesn't it? You want to close that and then multiply by 3.6. And x is approximately what? Right. Boom. It was a long one, I know.